understand how we define them, okay? But that should be easy because you understand basic biochemistry, yeah? Yes. So if I describe an R group as being non-polar, what element would you not expect to find?
Hydroxyl.
No oxygen, okay? So let's take a look at our non-polar amino acids. Notice, again, I don't want this to throw you, these are written in their ionized form. Remember, we said that's what we see in solution, that should not throw you, correct? Right? Right, so here is my, what's this here?
Alpha carbon.
My
Methyl.
amino group, my carboxyl group, and then what's designated in yellow is known as the R group, okay, what makes amino acids different. Notice when I look at these R groups, I do not see oxygen. So if I give you an amino acid and there is no oxygen in that R group, you are going to identify that amino acid as being non-polar, which means is it hydrophilic or hydrophobic?
Hydrophobic.
It is hydrophobic, right? Non-polar, it is hydrophobic. It wants to stay away from water, okay?
So there's no oxygen only in the R group,
In the R group, correct. Just in the R group. That's what we use to define these.
because there's always gonna be an oxygen.
That's exactly right. Good point. Very good point. Yes.
NH3 and NH2 are still an amino group.
This one is still, yes. It's an ionized amino group. Mhm. Okay. All right. On the other hand, what would I expect to see in my polar amino acids? I would expect to see oxygen. And I do with one exception. What up there is an exception to that? Cysteine. I want you to star this. It is a very important amino acid. Some references call it polar, some call it non-polar. We're not gonna identify it either way. But what we are going to remember about cysteine is that very important functional group that it has, which is unique. It's the only amino acid that has that functional group. What is it? It has that sulfhydryl group. So you can forget this, it's listed as polar on this particular slide, and make a note, this is the one that has a sulfhydryl group. Okay? My last category of amino acids are charged amino acids. Charged amino acids mean that they have a functional group that acts as an acid or a base in the R group. What functional groups would I expect to see in the R group of my charged amino acids? Carboxyl or an amino group. I further subcategorize them based on whether they're acidic or basic. Which of those would I expect to see in an acidic R group? Carboxyl versus basic? Amino, let's see if that has happened. Did that happen? Yes, it did, okay? Here are my R groups. These are my acidic amino acids. I can see very clearly the carboxyl group. These are my basic amino acids, and I see that amino group, okay? So again, we're not memorizing the properties of these groups. We are simply being able to recognize them, and their importance will become clear as we talk more about proteins, okay? We need to go one step further, so you're not behind at dastardly sixth period. So what I want you to do, we're gonna look at how we join together these amino acids. I want you on paper, whether you're taking notes in a notebook or on the PowerPoint, I want you to write two amino acids side by side, because you need to practice this structure. You're gonna see it many times. You wanna make sure you're comfortable with it. So go ahead and just write two amino acids, just put R for the R group, side by side, and let's figure out how we can join them together. And make two of them. Yeah, right there.
Is O minus OH same thing?
What's that?
O minus OH same thing?
Means that it's ionized, yeah. So you can write it however you're more comfortable with writing it. Nearly.
Are we just drawing two of the same thing?
Do you wanna write it ionized or non-ionized? Non-ionized. I don't like all those signs. Don't look at what I'm doing, I'll know.
That's right, so on the phosphate group, those O minuses are OH
draw something that looks kind of like this.
You forgot go on your second.
I hope, yeah? So what reaction is gonna join together these two monomers? Dehydration synthesis, meaning what do we need to remove? Water. Do you see where that might come from?
Yes.
Yes, where are we gonna get the OH from?
The OH.
From that carboxyl group, right? And then the hydrogen is gonna come from the amino group. These guys are gonna leave to form a molecule of water, which then allows for that bond to form between the carbon and the nitrogen, okay? Now, what type of bond is that? But what type of bond? You're right, it's called a peptide bond, but what type of bond is it? Hydrogen, covalent, or ionic? It is a covalent bond, okay, so that forms a covalent bond. You're gonna find, just to drive biology students crazy, that every covalent bond formed in dehydration synthesis in the biomolecules has a different name. They're just covalent bonds, okay, but it's called a peptide bond. And of course, we refer to this as a dipeptide, right, because we got two amino acids that have been joined together as compared to a tri, to a tetra, to a penta, to a polypeptide, yeah? Okay? And it generates a molecule of water. Yes, sir?